I'm Danny. I'm going to talk about meds, agenda. Okay, the goals, potato terminology, what meds are, where they're useful, and then where meds break, because meds actually break in a lot of places, and I'm not sure if everyone's aware of where they break. Maybe lots of folks are, but I think lots of folks aren't as well. So that's the goal of this topic, is to convey that point. So. All right, so increase awareness of, the deployment considerations is the primary thing, and to make operators aware, there are a lot of vendor, intricacies with implementations associated with MEDs and how they're used, and how an implementation actually handles meds and what behaviors they apply to those meds, and that's the main thing I wanted to get across in this. There are also some protocol issues that where meds are more likely to tickle things like persistent route oscillation that I'll talk about briefly as well. So there's nothing new or brilliant or earth-shattering here. It's just some things that folks need to be aware of, and it seems like not everyone's aware of those. So, okay, so before we start, how many folks here actually know what your med policy is? Good. How many folks accept meds from customers as a matter of policy by default? And what about from peers? Anyone accept meds from peers by default as a matter of policy? Okay, good. And how many folks don't know? You're not going to raise your hand, are you? Okay. So, all right. So potato terminology. I guess people mix. They use the potato term like hot potato, meaning tossing a hot potato back and forth between one's hands, and they use that to refer to closest exit routing. In other words, get it away from me as fast as you can get it away from me. And that's actually the default behavior, more or less, for closest exit or shortest path routing. And so hot potato equals closest exit routing in this context. Cold potato, which some people call it cold potato, I don't think it makes much sense, but it's best exit routing means you carry it to the place in the exit point on your network that you believe is the optimal exit point. Some folks, it's more commonly, I guess it's more intuitively referred to as best exit routing. So, and then mashed potato, which is probably more common than any, is and this could be string potatoes, whatever potatoes you like, potato salad, I don't know. But it's basically it's less than ideal. You think you're doing one thing and you're actually doing another, and it could be really suboptimal routing, which I'll show you in a moment. Why it's a bad thing at some points, and why things like aggregation can cause some really bad problems. So. Okay, so meds are multi-exit discriminator, or multi-exit disk is what it's referred to in the BGP drafts. It's formerly known as NRAS metric. It's optional non-transitive BGP attribute, which, if that means anything to you guys, if you follow the protocol, you know what I'm talking about. So, and the spec actually says it's used to convey, the optimal entry point, or to discriminate between multiple entry points between the same neighboring AS, which is another issue we're going to talk about in a moment. And then it's the lowest med is the value that's preferred. All preceding things like AS path and local pref, and longest prefix being equal. So, okay. Where meds make sense. So this is a really trivial diagram here to show you where meds make sense. The blue line there represents data flow. The red arrows represent the med that was sent from AS200 to AS100, and this is just showing you that the med of 5 made AS100 prefer the path that the blue arrows are being forwarded on. So that becomes the forwarding path, because AS200 sent a lower med value across the upper, the C to D path, and said this is the optimal way to enter my network, or this is the way I'd prefer you enter my network. And if AS100 honors those meds, it takes a more optimal path to reach the destination D.1. So that's what you see here. If that didn't happen, then AS100 would really have no way of knowing how to get to destination D.1. And it would be just as likely to send, S.1 would send to A would send to B, B to E, and so forth. And that's less than optimal if you've got a bigger picture and have the information. So, okay, so deployment considerations. Actually, these are the things I'm going to talk about now in just a moment. So, slides. So, meds break with aggregation. So this is something a lot of folks don't seem to be aware of. It's, aggregates are often basically, lots of folks, actually VJ talked about this yesterday, some I think, but aggregates are generated from multiple core routers or multiple, dual home routers within a network. Actually, I should just jump on to the picture here for you. And what happens is, in this case, for example, you've assigned 10.1.1.24 to a customer, but you own 10.1/16. And what happens is you just announce that aggregate from 1 or 2 or 10 points in your network. Maybe it's all your core routers, or core routers that are in the backbone center core of your network, or in a certain place. Typically, you don't announce your aggregates from like, a singly connected peer router, because if that router goes down and it's still announcing your aggregate, you'll black hole traffic. So what you see here is the aggregate's announced from this point, and it's the MEDs associated with that aggregate. And so then when someone wants to reach a destination, 10.110/24, they use the MED associated with the aggregate rather than with the more specific prefix, because they don't have the more specific information. And so they prefer this path always for all traffic going to that /16 prefix. And so that results in suboptimal forwarding paths, right? And this is basically, there have been some, I guess, some tests or some trials of people accepting more specifics. In other words, if you have pop aggregates or geographic regional aggregates associated with that /16, subsets of that, folks have tried to accept the more specifics and not announce them to peers, because typically this only applies. The aggregation typically only breaks if it's an adjacent AS. If it's a downstream AS, for example, this guy we're announcing some other prefix, it probably wouldn't apply because the MED would be associated with the next hop, presumably, unless you statically set your MED values. So anyway, that's what you see here. That's where MEDs break with aggregation. It gets really complex and really big topologies, and I've seen it be really suboptimal where this guy is doing closest exit or best exit routing out of his network, and he's got a complex topology, and he'll carry it all the way, say, from DC to San Jose and hand it off in San Jose, and then this guy carries it all the way back across his network to San Jose or back to DC, and so it could be really suboptimal. And so you need to be aware of that if you're accepting MEDs from an adjacent AS. Okay. So one of the large issues, and a lot of this stuff is actually clarified in the latest BGP draft. There's version 22 is just announced today on the IDR mailing list, and it's clarified a lot of these things. The problem is that most of the implementations that are out there are based on anywhere from from 22 revs of the latest BGP draft to RFC 1771, and or some broken version thereof, right? And so these are just a couple. There are actually several more vendor behaviors or implementation issues, and that you should be aware of with the implementations you're deploying. And it's a matter of like advertising BGP MEDs to IBGP peers by default, to eBGP peers by default, to confederations. I guess basically comparing MEDs between confederation eBGP peers and between regular eBGP peers, preferring no MED over a MED of 0. That's something that's been pretty flaky in the past. Another one is if there's no MED, it's the least preferable. It's worse than a max MED value. So being aware of what your vendor does. Considering max MED, 2 to 30 second basically the max MED value is unfeasible. Is something implementations have done. Comparing MEDs between different autonomous systems is a default behavior. We're going to talk about that in a second. And then a lot of you are probably seeing temporal route selection behaviors. In other words, what's happening is IGP churn. Actually, I have a slide on that. So I'm going to save that one for just a minute. But temporal route selection, the Cisco, I guess, parlance for that is deterministic MED is the way you configure it or unconfigure it. And it's something you need to be aware of in your network. And we'll talk about that in a second. So, okay, persistent route oscillation, RFC 3345 details this, provides some good examples. Daniel Walton actually did about an hour presentation on this at the February 01 NANOG, and it's pretty good if you got questions on that. If you haven't looked at that and you got a large network, you're probably seeing some of this route oscillation in your network if you're accepting MEDs, and so it's something you want to be aware of. So, okay, flap dampening and MED churn. So this is something actually the VJ talked about yesterday as well when they were changing their IGP metrics. The MED values were derived from IGP metrics dynamically, and when you change those IGP link metrics, if there's no kind of like state there, temporal state, in other words, keep the oldest MED value regardless, or the most stable route, then you're going to send a new MED value with your BGP update, and so that results in churn or instability in the network, and it can result in route suppression, route flap dampening, lots of instability. Actually, the link here. So this is the link Craig and Rob and some other folks did, and this is the document that VJ was referencing yesterday. And this document actually talks about there's a domino effect where IGP metrics change and they result in new MED values, and new BGP updates are propagated or new routes are advertised, and because of that, your peer prefers a different path, and that results in a new route being selected, and that's advertised and so forth. So there's a domino effect that that occurs from this. And so that's what, one of the things that this document talks about. So, okay, comparing MEDs between the different autonomous systems. One of the reasons this isn't a good idea is because most service providers use different policies to derive MED values. So if I compare MEDs between two different adjacent or two different peer ASs, then if one uses values, 1 to 10 for all their MED values, and another one uses really high values, then I'm going to always prefer the lower values, and so I'm always going to prefer sending that traffic to one peer over the other. That's one example. The same basically derives from the IGP metrics. If they use additive versus local, which doesn't make a lot of sense, but you could still do that if something's misconfigured. If they use the same IGP, like one of the things we used to see, one of the networks I worked on was the peers who used ISIS had the smaller metric space, and so we always preferred them over the ones who used OSPF because there was a huge metric space and they typically use that. And so we, if MEDs were employed for that purpose, you would always use the lower MED values. So in that case, the peer that used ISIS. So. And then, they may not even, your peers may not even be aware that they're sending you MEDs or accepting MEDs from you. And so, or they may not be sending them at all. So if you're comparing MEDs between different ASs and there's no MED value, and your implementation compares MED values of nothing, or it makes it 0, for example, which is what the new spec says. It says if there's no MED value, consider it an MED value of 0, then that's going to be something, and that peer is always going to win over a peer that's sending you MEDs. So. Security considerations, this is pretty intuitive, I think. If you accept MEDs from peers, there are lots of attributes you can use to influence route policy or, forwarding path selection from your peers. And so MEDs is one more thing they could use to manipulate you, manipulate your path selection. Given you could do this with local pref, ASPath, anything else, but MEDs make it a little easier, and if you don't have checks on MED values, then it's something that that they may be able to get away with. There are lots of things you could do with this from that front. So, okay, BGP update packing. Basically, the spec allows, BGP spec allows for all the withdrawals you want to be sent in an update message. You don't have to send attribute information for those because BGP only announces the best prefix. Well, you've also got the capability, if the attribute set, like ASPath, NextHop, MED, all the attributes associated with the set of prefixes are exactly the same, then you can pack, it's referred to as update packing. You can put all those prefixes in a single update message. And what that provides is you don't have to send lots and lots of update messages. And there's a huge benefit in processing overhead, link bandwidth save, that kind of thing. And if you're accepting MEDs from peers, then, and you get some huge array of MEDs, then you can't pack those updates or those routes with other routes that have a similar set of attributes. And so there's an observable, I guess, decrease in the benefit of that from accepting those. So with that said, conclusions are MEDs work in lots of places. They break in lots of places. You should be aware of that. They're not just something you should turn on and say, oh yeah, we accept MEDs. We do, this is some marketing thing, because you could actually be making things worse in the long run. You should be aware of the difference. There's a draft that I'm working on. VJ's working on it with me, and I've got some really good feedback from some other folks. And it's documenting everything in this as well as several other things, and it'll be available soon. It's probably going to, I don't know how many people in here actually know what GROW is. It's Global Routing Operations Working Group in the IETF. It was a prefix taxonomy working group, I think, and it's kind of the operational side of IDR, I guess would be one way to characterize it. And if you're not on the mailing list and you're interested in IETF things, that might be a good way to step into the routing side of the IETF. So, but that's where this belongs. Dave Meyer, I think, and VJ maybe actually chair that working group. You can find a link to it on the IETF webpage. But other than that, that's all I had. I want to thank Craig and John and VJ for input on this presentation and on the draft, actually. And any questions?
Well, while Randy's walking, I have a question. Is there anywhere where it's published what vendors do what stupid things with MEDs? Because it's, or do you have to just kind of tease it apart from your vendor?
Yeah, I'm not aware. You could maybe a vendor could speak to that. I think it's been teased apart in the past, and the biggest problem is if iOS, for example, did something in one revision, they do 3 other things in the next 12 revisions. So they're getting better, and probably better defaults, but at the same time you got to be aware of what's deployed on your network. So, Randy, go ahead.
Randy Bush, IIJ. To my memory, the first presentation of Watch out for MEDs, don't do it in special circumstances at NANOG was in February of 1996. We still see the mess today. This is analogous to the be careful of using the network at NANOG. I think the only way you're going to get this across, Danny, is to start showing some actual measurements, actual trace routes, actual disgusting examples, and rubbing people's nose in it, because it's getting worse, not better.
Right. Absolutely. And, you know, and the marketing fluff around, you know, like we do best exit routing, for example. I actually did a bunch of trace routes at a previous provider I worked for and said, look, you know, we're taking the least possible, I mean, the worst path.
For our customer.
Yeah, for our
It
customer.
offloads our link. But it's,
absolutely. So, and, you know, all I can do up here is say, you know, be aware of what you're doing, you know.
no, I think we actually have to show some.
Yeah, no, so I mean, if folks
We
can
actually
demonstrate.
see this is happening right now in your network.
Right. Yeah, no, I completely agree, absolutely. So and it's the same goes actually for the persistent route oscillation, which I actually didn't say a lot about, but meds are the primary trigger for persistent route oscillation, and folks are, oh, it's not hitting me, and then, you know, if they go look, you know, I mean, one network I looked at was seeing this with, you know, over 1,000 prefixes in their network continuously, you know, advertisements were continuously oscillating, and so, you know, that's something, until you go look, you know, yeah, it's not bothering us, we're not seeing it. Well, that's because you're not taking the time to notice it, so. Go ahead.
Tony Armato, Saving Arrow. One thing I wanted to mention is in regards to your aggregation section that you were talking about in regards to meds, is there are ways for you to not suppress more specific routes, which will still include the med and the original AS path when you're aggregating specific routes within BGP.
Oh, no, absolutely. I'm completely
I
aware of
didn't
that.
know-
But then, you know, I would rather tell folks to announce aggregates and not punch holes or announce subsets of aggregates for an MED, because, you know, there are lots of issues with accepting more specifics for aggregates as well. And so that's typically like the large folks, anyone that runs, you know, at least a tier 1 network for their network aggregates don't like to punch hole. But yeah, all implementations have a mechanism to do that. Absolutely.
I just want to make sure.
Okay. Any other questions? That's it. Okay. Thank you.
Thanks, Danny.